Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 14, subject physics, lecture number 19, current electricity. Now, first, electric current. First, before going into detail of current electricity, I will explain electricity. Current electricity. Current electricity means the flow of anything which produce four effects: light, first produce light, heat, sound and motion. So anything which produce four effects, light, heat, sound and motion, is called is called electricity. Electricity is further divided into two branches. First one is called static electricity. You studied this in chapter number 13. And the second is current electricity. You studied this in chapter number we will study this in unit number 14. We will start this now. First is current electricity. Current electricity is current electricity is the flow of charges in state of motion. If electric current is due to the flow of negative charges, flow of electron, then it is called electronic current. And if it is due to the flow of positive charges, it is called positive current, conventional current. Electric current is a flow of electric charge, electron moving in a conductor such as copper wire. Electric current. What is electric current? An electric current is formed by moving charges. If positive charge is moving, electric current will be the current is called conventional current. Charges is flowing, so electric current. So electric current is due to the flow of negative charges. It is called electronic current, and it is called electronic current, and it will be from the negative terminal to the positive terminal. An electric current is a measure of the rate of flow of electric charges through a given cross section of a conductor. Electric current is charge per unit time. Is charge per unit time. Charge per unit time. Q represents charge and T represents time. Q represents charge and T represents time. Electric current is measured in ampere. The unit of electric current is ampere, symbolically represented by A. The unit of charge is coulomb. And the unit of time is second. Unit of time is a second. Now, this I represents current, and it is the unit. Q represents charge and coulomb is the unit. T represents time and second is the unit. Conventional current flow. Conventional current flow is from the positive terminal to the negative terminal of the battery. This will be the direction of flow from positive to the negative terminal of the battery. In electric circuit, electric current is considered to flow out of the positive terminal from the positive terminal of a power supply to the negative terminal of the battery. There are no charge carrier flowing in this direction. In many conductors, charge carrier both positive and negative are flowing in both direction. Electric current is due to the flow of positive charges and due to the negative charges. So whether you consider the positive charges, whether you consider the negative charges, both will explain the nature of current. Charges is flowing. If you have three fundamental particles, you cannot distinguish between these two. Which one is electron, which one is proton, and which one is electron, proton, and neutron. If we give negative sign to this one, automatically you will understand it that it is electron. If you give it positive charges, you will say it proton. If no charge, it is a neutron. Now, how do we measure electric current? Electric current is measured using an ammeter. Ammeter is a device used for the measurement of electric current, and it must be connected in series. It must be connected in series, or more commonly a digital multimeter. A digital multimeter. So, for multimeter is used to measure resistance, voltage, and current. All these three things are measured with the help of uh, multimeter. That's why it is called multimeter. For resistance we use ohm meter. For voltage we use voltmeter, and current is measured with the help of ammeter. But multimeter is used for all these three quantities. In order to properly measure, all the current must flow into the meter. Simply, it means that if you want to measure current, the device must be connected in series. Now, galvanometer. Galvanometer is used to measure small amount of current. Small amount of current, and it must be connected in series. A galvanometer is an instrument for detecting and measuring electric current. The term galvanometer is commonly used by a scientist, an Italian scientist, and it is named after the name of the scientist. Galvanometer were the first instrument used to detect and measure electric current. Galvanometer is an electromagnet. Simply, you can say that this coil is electromagnet. This coil is electromagnet. Current is flowing through this one, and it is placed between the poles of a magnet. It is placed between the poles of a magnet. So when it is placed between the poles of a magnet, let's say it is north pole, it is south pole. When current is flowing through this coil, uh, it will exert magnetic force on this coil and will rotate the and will deflect the needle of the galvanometer. So when according to Faraday, a scientist, you will study this in the coming chapter, in the coming next chapters, that when a current carrying coil is placed between the poles of a magnet, it will experience magnetic force which deflect the coil. Faraday law. Faraday law. Galvanometers are used as gauges in cars and many other applications. The greater the current passing through the wires, the stronger the galvanometer interact with the permanent magnet. How galvanometer works? Solenoid creates magnetic field when current goes through This is solenoid, coil carrying current. Coil, when an iron is wound round, and when an iron core is wound round, it is called solenoid. When current solenoid creates magnetic field when current goes through. That magnetic field tries to line up with permanent magnetic field, moves the pointer in the process. More current, more pointer moves. More will be the current, more will be the deflection. If current is flowing through the coil, coil will experience magnetic force which deflect the coil. More will be the amount of current, more will be the deflection. Ammeter. An ammeter is an electrical device used to measure the amount of electric current. Ammeter must be connected in series. Electron flow through the circuit also flow through the ammeter. If an ammeter were connected in parallel, there will be more than one path for the current to flow. So it will not measure the current accurately. So it must be connected in parallel in series. So if you want to measure current, you will use ammeter, and when you use ammeter, it will be connected in series. It will be connected in series. So it must be the current must flow through the ammeter. So current is measured with ammeter. Ammeter will be connected in series. If you connect it in parallel, it will there will be error in the reading. Now, if you want to convert a galvanometer into an ammeter, you connect a shunt resistance with the galvanometer with the galvanometer in parallel. So with the help of you can convert galvanometer into an ammeter. So voltage across the shunt resistance will be Is Rs, and voltage through galvanometer is Ig Rg. Ammeter instrument used for to calculate the magnitude of current, to measure the presence of electric current in a circuit. Galvanometer detect the strength and direction of small current in a circuit, flowing in a circuit. Potential difference. Voltage. Potential difference across the two ends of a conductor causes the dissipation of electrical energy into other form of energy as charges flow through the circuit. The unit of potential difference is volt. A potential difference of 1 volt across a bulb means that 1 coulomb of charge or 1 ampere of current that passes through the bulb consume 1 joule of energy. V is equal to W divided by Q. W is energy. Q is charge. V is voltage. V is voltage. So 1 volt is equal to 1 joule per coulomb. 1 joule per coulomb. V is equal to W divided by Q. W is equal to QV. Work is 1 joule when a charge of 1 coulomb flows and produce a potential difference of 1 volt. So when 1 volt of potential difference is produced when a charge of 1 coulomb flows, the amount of energy consumed or produced will be 1 joule. Potential difference. The easiest way to think about that batteries do is to use a water analogy. For example, batteries lift charges to a higher potential. There is a potential difference between one end of the battery and the other, positive and negative. Batteries store potential energy as chemical energy. Now, if you can see, when you carry water you want to carry it to some certain height, you give energy, and this energy will be stored in the form of potential energy. For example, you want to take water from this point to this, you consume energy, you use your own potential energy, and it is stored. If it flow in this direction, it will flow without your energy, because you this energy is stored in this water in the form of gravitational potential energy. So chemical energy is stored in the cell or in the battery, which make the flow of positive charges, or which make the flow of negative charges. Potential difference. Water flow from higher potential to lower potential. The water at the top of the waterfall has a lot of energy. The higher the waterfall, the more energy the water has. At the bottom of the waterfall, the water has less energy. The voltage across part of an electric circuit is like the distance that the water falls. The higher the voltage, the more energy the current has. Definition: electromotive force. The force EMF. You can write EMF. The force which produces the motion of electron is called electromotive force. Electromotive force is the energy transfer per unit charge when one type of charge of energy is converted into other form of energy. Electromotive force is the electrical energy transfer per unit charge. EMF is equal to W divided by Q. The definition tells us two things: that EMF is measured in joules per coulomb, that it always deals with the supply of electrical energy. Simply, you can say that potential difference is the energy dissipated in an electrical appliances. For example, tube lights convert electrical energy into light energy. So the amount that it have consumed, it have converted from one form into another form is the potential difference, and the energy given to the tube light is EMF. For example, if 240 volt is given to the tube light, this is EMF. This is EMF. If tube light use 2 volt, this 2 volt is a potential difference. Listen again. If tube light have given 240 volt of energy, this is EMF. If it use 2 volt, this 2 volt is called potential difference. So the amount of energy which is converted into other form of energy, or which is utilized is called potential difference. And the amount of energy which is given is called potential difference. The strength of the battery is called EMF. EMF is the strength of the battery. Strength of battery. Strength of battery is called EMF. And the energy used, for example, EMF is V plus IR. If R is the internal resistance of the battery, and I is the current, so some amount of energy is used to overcome the internal resistance of the battery, and some amount is converted into voltage, into potential difference, into other form of energy. And EMF is the strength of the battery, So if it is 24 volt, 2 volt, let's say 2 volt is used to overcome the internal resistance of the battery, 18 volt will be given to the electrical appliances. 22 volt will be given to the electrical appliances. If current flow is 0, potential difference will be 0, because if no voltage is given to the tube light will not produce light, so it will not consume electrical energy. So potential difference is 0, but the strength of the battery will not be 0. So EMF will never be 0. If current is 0, potential difference will be 0, but EMF will not be 0. EMF is the cause. EMF is the cause, and potential difference is the effector. And potential difference is the effector. Now, electromotive force. V is equal to energy EMF per unit charge. This is different type of relation, and it is used under different circumstances. In some situation, EMF is equal to potential difference. Electromotive force of an electrical energy source is the work done by the source in driving a unit charge, in carrying a unit charge around a complete circuit. Work done, amount of non-electrical energy converted to electrical energy. Different perception. This is the difference between EMF and potential difference. EMF is the maximum potential difference between the two electrodes of the cell. When no current is flowing, if current is 0, EMF will be present. If current is 0, EMF will be present. If current is 0, potential difference will be 0. It is independent of the resistance of the circuit. It is proportional to the resistance between the given points. The term EMF is used only for the source of EMF. It is measured between any two points of the circuit. It is greater than the potential difference between any 2 points in a circuit. However, potential difference is greater than EMF when the cell is being charged. Means sometimes it is greater. So simply you can say that EMF is the cause and potential difference is the effect. Now, measuring potential difference. Use voltmeter. You will use voltmeter for the measurement of voltage. It must be connected in parallel. Measuring the potential difference in across bulb. You will connect it in parallel. You will measure potential difference across the bulb if there is a device like bulb. So you want to measure electric current through it. It must be connected in parallel. Voltmeter must be connected in parallel. Now, definition of statement of Ohm law. Ohm law states that the electric current flowing through a conductor is directly proportional to the voltage and inversely proportional to its resistance. Current is directly proportional to the voltage and inversely proportional to the EMF. You cannot write V is equal to directly proportional to current because I is directly proportional to voltage. This is derived quantity and this is base. So voltage depends on the current, but current does not depend on voltage. Current resistance is inversely proportional to the current. So V is equal to IR. This will be the equation. I is directly proportional to voltage and resistance. So after simplification and experimentation, you can simplify it. Now, R is equal to V by I. After simplification, R is equal to V by I. The unit of resistance is ohm, represented by omega. The unit of voltage is 1 volt and the current is 1 ampere. So the resistance is said to be 1 ohm. If a current of 1 ampere flows and produce a potential difference of 1 volt. Now resistance. Resistance is the property of a conductor to resist the flow of electrons through it. It will oppose the flow of charges. It will oppose the flow of charges. Ohm law. According to Ohm law, R is equal to V by I. Unit is ohm. Unit of resistance is ohm. And if you write R is equal to V by I, 1 ohm is equal to 1 volt 1 ampere. If resistance is 1 ohm, the resistance is said to be 1 ohm. If current of 1 ampere flows, if current of 1 ampere flows and produce a potential difference of 1 volt, the resistance is said to be 1 ohm. Resistance is said to be 1 ohm. Resistance is the property of a material. Resistance is the property of a material. Now, thank you, students. We will study this chapter. I will go into further detail. I will explain resistance more in the next coming lecture. Thank you, students. Allah Hafiz.